All right, in this video what we're going to do is talk about the set operations on finite sets. Remember, the word finite just simply means countable. In other words, we can count the number of values in a given set. For example, in number 1 here it says we have set A that contains, there are 4 elements in set A. The elements are 1, 2, 3, and 4. In set B, we have 1, 2, 3, 4, 5 elements, and those elements are 2, 4, 6, 8, and 10. So if we want to find the union of A and B, it means that the element only has to appear in at least one of them. So let's start with set A. It contains the numbers 1, 2, 3, and 4. So far, 1, 2, 3, and 4 make up the union of the two sets. But have we listed everything that's in at least one of the two sets? Well, let's start with 1. 1 is in A, 2 is in A, 3 is in A, and 4 is in A. Let's look at set B. It contains 2 and 4. Well, 2 is already listed, 4 is already listed, so we now can include 6, 8, and 10. So the union then of set A and B is the set 1, 2, 3, 4, 6, 8, and 10. So if you go back to the sets again and just make sure that these elements appear in at least one of the sets above, then that is the union of those two sets. What about the intersection of the two? The intersection means that it must belong in both sets. So when we're looking at the elements, 1, let's start with 1. 1 is not in both sets. So can we find values that occur in both of these sets? Well, it looks like 2 is in both sets. And what else? 4. Looks like 4 is also in both sets. So the intersection would be 2 and 4. So you can think maybe as the intersection is more restrictive, it has to be in both sets in this example. For the union, it only has to be in at least one. Notice the elements 2 and 4 that we listed in the union do belong there because 2 and 4 appear in at least one of them. Happens to be in both of them in this example. Let's take a look at example 2. In example 2, we're looking at the sets M and N. The first set M contains 4 elements. Set N contains 3 elements. So the union means that the values only have to occur in at least one. So let's start with set M. The elements -3, -1, 0, and 2 appear in at least one of them. When we look over at set N, well, 1 is not listed yet, so we need to put 1 in there. 3 is also not listed, we'll put 3 in there. And 5 is also not listed yet, so we had to put 5 in there. Now typically we put these in order, so let's go ahead and switch the 1 and the 2 around. And let's just verify our answer. And we do that by looking at element 3. Is 3 in at least one of the sets? Yes. Is -1 in at least one of the sets? Yes. 0, yes. 1, 2, 3, and 5. So we've listed all of the elements that belong in one or the other. It could be in both. So the union of the two contains 1, 2, 3, 4, 5, 6, 7 elements. Now what about the intersection? We're looking for values that occur in both of these sets. So what about -3? No, it's not in the set N. -1 is in the set M, but not in N. 0 is not in either one, and 2 is not in both sets. So since there's no element that belongs in both sets, what we do is we simply write an empty set. An empty set can be written one of two ways, either 2 brackets with nothing inside, or we could have this symbol here, which is kind of an O with a line through it. So these both represent what we call the empty set. Once again, it's the empty set because the two sets do not share any elements. Let's take a look at another example. All right, in example 3, we have two sets. We have C and D. C contains two elements, -4 and 0, and D contains the elements 0, 2, and 7. So the union, we have -4. Let's see if we can put these in order as we go here. 0, 2, and 7. Have we listed the elements that belong in at least one of them? Yes, -4 belongs in the first set. 0 actually belongs in both, but that's okay. It belongs in at least one. 2 in the second, and 7 in the second. So the union of C and D contains or results in 4 elements, -4, 0, 2, and 7. What about the intersection? What element occurs in both? That is the value 0, the element 0. So the intersection contains one element. Be careful, saying 0 is not saying the empty set. 0 is a number, it is an element that is in both sets. One more example, example number 4. We're looking at sets Q and R. Q contains 2 elements, R contains 4. If you notice here, both elements that are in Q also reside in R. So what we would say here is that Q is a subset of R. So the union then would be 1, 3, 5, and 7. And then the intersection, what value occurs in both of these sets? That's pretty simple. It's 3 and 7. So the union contained 4 elements. The intersection contains 2.